these live sessions. My name is Maud Nale. I'm the communications lead at Digital Earth Africa. It's an honor to have you with us. Today is a very special kind of live session. We will start with the live session, yes, and thereafter we will host the Digital Earth Africa and African Women in GIS Technical Challenge Winners Announcement. I'm so excited. Let's get started with our program leaders. To welcome onto the stage the facilitator for today's session. Her name is Victoria Nima. She is the junior developer at Kartoza, and today she's going to be talking all about mapping water extent. I'm so excited. She is no stranger here to the platform and to the family. So Victoria, when you're ready, the virtual stage is yours. Over to you.
Thank you, Maud, for the introduction. I will just...
Yes, we can.
Good. So today we'll be talking about mapping water extent, and we'll be focusing on the notebooks that we have available in the DE Africa Analysis Sandbox. So for those who are new, the Sandbox is a cloud-based computational platform that DE Africa provides that operates through a Jupyter Lab environment and gives you a free but limited computer resource. I think the biggest sandbox is 32 GB, and you can use it to explore the DE Africa data and products that we have, and also run your own analysis using the notebooks that we provide, or using or you can customize them to run your own unique analysis. Now, mapping water extent is important because water bodies, both inland and coastal, are affected by climate and human activity, and in turn, they affect climate and human activities. Therefore, we need to be able to monitor the location, the extent, and changes happening to these water bodies in our strive or road to achieve sustainable development. Satellite remote sensing is one of the most efficient and widely used methods for monitoring water bodies because of its fast response, its wide field of view. You're able to monitor for an entire country, for example, at a time, for its periodic observation, and also its low cost, especially the open access ones. Digital Earth Africa provides open access to Earth observation datasets for cost-effective and accurate monitoring of these water bodies. In the analysis sandbox, like I mentioned, we do have quite a variety of notebooks that deal with mapping water extent. In the real-world examples folder, as I'll be showing in the notebooks, we have the water detection using Sentinel-1, the mapping long-term changes in water extent using WRFs, or the water observations from space products. We also have the determining seasonal extent of water bodies using Sentinel-2. In our use cases, which are usually made up of multiple notebooks, we do have the monitoring water extent use case, and we also have the surface water count use case. These notebooks contribute to the following indicators in support of the global indicator framework for the Sustainable Development Goals. We have the level of water stress indicator, and we also have the change in extent of water-related ecosystems over time. We'll be starting off with the water detection using Sentinel-1. The products used, or the Africa products used in this notebook, are the Sentinel-1 analysis-ready data. Now, the case for radar is made because although coastlines and water extents can be mapped using optical data, these images can be strongly affected by weather, especially through the presence of clouds, which then can create non-clear or unclear images, which are not suitable to be used in mapping water extent. So to address this problem, especially in tropical areas where we have large swaths of land which experience cloudy conditions, we can use Sentinel-1 data as a good alternative for mapping water extent, as radar data is largely unaffected by cloud cover. The aim of the notebook, the water detection notebook, is to show how to use Sentinel-1 data to build a classifier using a threshold, and which can then determine whether a pixel is water or land. For this notebook, the area of interest is, I'm not sure how to pronounce that, but it's in Gambia. So we can see in the first image, the RGB, we have an RGB composite from Sentinel-1 data, where the channels we've used for the red, green, and blue are the VV polarization, the VH polarization for green, and then a ratio combination of the VH and VV polarization data. On screen, we can see now open water is usually can be seen as the dark blue surfaces, as you can see from where I'm tracing with my mouse. And then we can have we have tree cover, which appears due to its relatively high VH signal. And we also have urban areas represented in yellow. And we have these areas that are bright red, which are likely to be water withstanding vegetation. Now, using Sentinel-1 and applying a threshold, we can then average the results, the classification result over the time period. In this case, this example was run over the entire images collected over the entire year of 2020. Then we applied a threshold, the threshold using to classify images as either, classify pixels rather as either land or water, and then we average those results. Now you can see here pixels with a value of 0 or the dark red are pixels that are always classified as land. Pixels with a dark blue, which is an average value of 1, are pixels that are always classified as water. This is a good indicator of determining water extent. For example, this river, as you can see flowing here, these are the dark blue areas are pixels that are always classified as water. So they have water throughout the year. The shoreline of this area or wetlands have usually taken on a mix of values, showing that they're sometimes during the year classified as land and sometimes during the year classified as water. We can then use in the same method that we used for the average of the classification, get the standard deviation of the classified pixel values to determine whether an area is an actual shoreline. So in this case, as we can see here, areas with a high value that is colored yellow or green are either shorelines or wetlands. This is because it indicates that majority of the year, they are classified as water. So they frequently change between water and non-water. So this method is a good method of determining water extent and also getting wetland areas and also determining shorelines or coastlines for a specific area of interest. Next up, we'll talk about the determining seasonal extent of water bodies using Sentinel-2 notebook. Now, the aim of this notebook is to show how to use the Sentinel-2 derived modified normalized difference water index to show the seasonal variation in the areal extent of a water body. So as we can see from the GIF on screen, using the M and WY, the dark blue pixels are what are likely to be water. And then we have the dark red pixels are what is likely to be land. And you can see the water extent or the areal extent of the water body of interest changes over time. When running the notebook, please note that each season is in this example, the default example is defined as 3 months long, but there are options of changing this to 1 month or even larger months, depending on what you want your season defined as. Next up, we can see from the MNWI derived from Sentinel-2, we can get the average area of the water body from the period of interest, which is 2017 to 2021. Now, at the bottom of the screen, we have two images. We can see the image on the left, that is the 2019 September image is the aerial extent of the water body of interest at its lowest season. Then we have the image on the right that shows the aerial extent of the water body of interest at its highest season. And we can also confirm this using this graph. So as we can see, during this time period of 2019 in September, we have the lowest area of the water body. Then we can see from the graph also in 2021, in March, we have the highest area of the water body of interest. We can also determine the change in water extent by plotting this type of image, where we can see the pixels that remained as water throughout. We can also see the pixels that changed from water to, from no water to water, as you can see indicated by green. And we can also see the pixels that remained as land throughout, which is the pink. So this shows the change in water extent from 2019 March to 2020 March. So again, pixels that remained as water are indicated in blue. Pixels that changed from 2019 to 2020 March from no water to water indicated as green. And then we also have the pixels in yellow. They're very small. I hope you can still see them on screen where I'm pointing with my mouse. These are pixels that change from water to no water. The next notebook we'll talk about is the mapping long-term changes in water extent using the water observation from space annual summary product. So this product, a bit about this product is that the WAFS products, we have the feature layers, the annual summary, and also the all-time are all generated using the WAFS classification algorithm by applying the WAFS classification algorithm on Landsat satellite data. Now, what this the product shows is that the frequency of a pixel being classified as wet for each year. So we take the count or the ratio of the count of the total number of clear and wet observations for a pixel. And we also take the count of total number of clear observations, and then we divide them to get the WAFS frequency. The advantage of this product is due to its being derived from Landsat, it's available for a large temporal range that is 1984 to present, which makes it suitable for mapping long-term changes in water extent, as opposed to the previous notebook where we used Sentinel-2 data, which is only available for 2017, which now makes Sentinel-2 better suited for seasonal mapping seasonal changes instead of long-term changes. On screen, you can see a video of the change of the same water body that we used in the Sentinel-2 notebook, but using now the WAFS annual summary. The darker pixels, mostly at the center of the image, are pixels which are classified the most frequently as wet throughout the year. So these are values with the closest value to 1. And you can see how it changes for the different years. Using the same method as we use in the Sentinel-2, we can plot the area, the change in area for all the years that we've loaded the data for. And as we can see, the aerial extent of the water body for the lowest year compared to the aerial extent of the water body for the highest year. As you can see, this is 1992, which corresponds to this point at the graph. We can see is the lowest point, and our highest year is 2021, which, as you can see from the graph, it's here at the highest point. We can also see the change in water extent between the two years, 2019 and 2021. So indicated here is pixels that remained as water between the 2 years. Then we can have the green as pixel that changed from no water in 2019 to water in 2021. And then we can see the pink are pixels that remained as land throughout. The conclusion from this two is that there was quite a, which is supported by the graphs before, is that there was quite a huge increase between the aerial extent of the 2019 to 2021, which could be contributed by multiple factors such as rainfall, which we'll see in later notebooks. We can also see that depending on our aim, for example, the Sentinel-2, we were aiming for a short-term changes, and in the WAF's notebook, we were aiming for mapping long-term changes in the water extent. We can get quite different results. They both do show an increase in the area of the water body, but between the two time periods, but the location of pixels can vary. So that is something to be careful about when determining mapping extent, is whether you want to see the short-term changes or the long-term changes. Next up, we will we'll be going into the use cases. So we do have the monitoring water extent use case that I mentioned previously that uses multiple notebooks. So the first notebook that it uses is the mapping water extent and rainfall using Sentinel-1 and CHAPS data. As I previously mentioned, the Sentinel-1 is good for areas with that experience heavy cloud cover as an alternative to using the optical methods like Sentinel-2 or Landsat or WAFs, which is based on Landsat. Now, the Sentinel-1 water index is also a good alternative because it has a higher resolution of 10 meters compared to Landsat's 30 meters resolution, and also has a higher temporal resolution of 12 days, 6 to 12 days, depending on the area, compared with Landsat's 16 days. Now, we do also have the CHAPS data, which comes as either monthly or daily and gives rainfall estimates for an area from rain gauge and satellite observations. Now, the aim of this notebook is to use the above products to map the change in aerial extent of the water body and compare the change with the average rainfall received over the time period for the water body of interest's catchment area. Now, as you can see on screen, we've compared the area of the water body over time to the rainfall received. And as you can see, there is quite a bit of correlation of the increase in rainfall, but a delayed. So you can see those as an increase in rainfall happened, also an increase in the water bodies area also happened. In this image, we can see the change in water extent. So the green is presented as land, pixels that remained as land between 2018 and 2021. We also have the light blue are pixels that remained as water between the two selected time periods. And then we have the dark blue, which is water that pixels that were not water in 2018 and are now classified as water in 2021. A small area that we can't really see but is actually present is dark green pixels, a zoomed in image will show that there are some areas where they were classified as water as in 2018, but were classified as land in 2021. We now also in the monitoring water extent use case have the monitoring water extent and rainfall using WAFs, the WAFs data and the rainfall CHAPS data. As I previously said, the WAFs data is derived by applying the WAFs classification algorithm to Landsat satellite data. The difference between the WAFs feature layers and the WAFs annual summary is that the annual summary is the frequency that a pixel was classified as water throughout the year. But the WAFs feature layer is a water and non-water classification image for each Landsat scene process for the occurrence of water. So this is like for a single time step, you will have a WAFs feature layer, which is an image that shows the pixels classified as water and pixels classified as non-water. The temporal range is the same as the WAFs annual summary, so it's available from 1984 to present, which makes it suitable for mapping long-term changes in water extent. Again, the aim of the notebook is to use the above products, the WAFs feature layer and the CHAPS monthly data to map the change in aerial extent of the water body and compare the change with the rainfall, average rainfall received in a catchment area for the water body. As you can see on screen, the graph is quite different. It's same period of interest, but quite different to the Sentinel-1. Although the trend is the same, exact values for specific time periods will not necessarily be an exact match. So we can see in the image on the right, Landsat, pixels that remained land throughout the two time periods. So for 2018, pixels were classified as land, and 2021 pixels were also classified as land. We also have the light blue, which is water that was classified both in 2018 and 2021, pixels classified as water. Then we do have the dark blue, which you can clearly see around the edges, where water was pixels were classified as non-water or land in 2018 and were classified as water in 2021. So that's why we see water appeared. And then we now have a dark green areas as here on the south bottom part of the picture, where these were classified, pixels were classified as water in 2018, but were classified as land in 2019, which is where we say water disappeared. The trend is the same, where we see sort of a delayed reaction to rainfall. So as the rainfall increased, we also see a delayed increase in the water body area. Here's just a comparison of the two methods using the WAFs annual summary and using the Sentinel-1 water index. And you can see that although the exact values may not necessarily match, the trend is the same, showing they can be used for monitoring the water extent. Also, we can see the pictures are largely the same with just a few differences. For example, the area that water disappeared between the two is not exactly the same, but the range of values is close. We also have another use case for mapping water extent, which in this case we use the WAFs annual summary to classify an area pixels as water or land, and then export the detected water bodies as shape files. So the area of interest to note is a region in Isinya County of Kenya. And as you can see, the results of the classification for that area of interest, I hope it's clear enough that we have this dark blue area, all this dark blue area, including a sort of a I would say, sparse, not connected water bodies, as you can see here at the edge of the image, were detected for the area of interest. A zoomed in look is for this section of the water bodies could be a river spanning this entire area along the boundary. Now, in the notebook, we plot the WRF's annual summary for a small section of the water bodies detected. And as you can see from these, the multiple graphs, that this middle part of the water body was consistently classified as wet or water between 2007. So from here, 2007 to 2010. But it was only classified as water in the annual summary between 60 to 70% of the time in 2021. So the highest, just to note in the color image is that pixels that were classified as the lowest count are in the dark blue, using the dark blue color, and then with the highest wet count are with or values close to 1 are with the yellow light green color. We can also see the average frequency of water observed for this selected water body over time varies greatly. So like in 2000, the average frequency was 0.2, but as it progressed between 2008 and 2012, we have the highest frequency where water is observed in the water body. Then it continues to dip as we come closer to 2020. So before we finish, I will just go to the notebook so you can see an example. So the example that we'll be picking up is in the real world examples, just to have a good view of the notebook. And we'll be picking up the monitoring radar water detection, just so you can see what's about. Because there are multiple notebooks, I'll not go into detail for all of them. Okay, so you can see most notebooks follow the same format. So we have a background section where we can just give a background of the problem we're trying to solve with the notebook. In this case, this was focusing on determining shorelines or coastlines by detecting water bodies using Sentinel-1. So we start off by loading the packages, and then we determine the area of interest. So we define the time range we want to load data for, and the latitude, longitude, and buffer for our area. We then load Sentinel-1 data for our area and time of interest. As you can see, this is the VV polarization, the VH polarization, and can also see an RGB composite made up of the two polarizations. We also apply speckle filtering to the Sentinel-1 data, which just improves a lot of the speckle or noise that you can see in the images. So you can compare these, the VV and the filtered VV. The noise, the previous image is much more noisy than this filtered image. We can also see the comparison of the two images, the values for our area of interest. Now, in this case, we apply a threshold to the VH values using the minimum threshold function. And in this case, this is our -25 is our threshold value. So using this threshold, we then now classify all the VH images we have in our image collection as either, so for each image we get either water or none or not water. like I previously said, after we classify all our images, we then plot the average classified pixel value over time. So the dark red areas of pixels that are always land, and the dark blue areas are pixels that are always water. And we can also compare result using the standard deviation instead of the average value. So you can see how frequently images are switched between being classified as water and land. So the dark yellow are pixels that frequently throughout the year of 2020 that we defined frequently change between water and non-water. And then our pixels always classified as land or water always remain as dark blue. So they have a standard deviation value of 0. Are there any questions so far?
None at the moment, Victoria, and maybe for the sake of time, we can proceed. Thanks.
Sure. Okay, I think that's it for the live session. If you have any questions, please feel free to reach out. I also, before I forget, we do have the Africa training course. The link is on screen, the land.digitalearthafrica.org, and you can use the course. It's free, and you can just go through it to be able to have a better idea of how to maximize the use of the analysis sandbox. We also have the news. So we also have the website, and we also have a newsletter you can subscribe using through the help desk .digitalearthafrica.org, and we also have the weekly live sessions that we run once a week, alternating between English and French. So thank you everyone for your time.
Thank you so much, Victoria, for your time. I'm not from a science background, I'm from communications, but I must say my body of knowledge in science is growing. Today, I learned about water extent. I learned about water observation from space, Sentinel-1, Sentinel-2, and chirps. And every single week, that body of knowledge is growing. I certainly enjoy being here on these sessions. So thank you so much to you, Victoria, for the very informative presentation on the mapping of water extent. Friends, we're going to move on with our program, and it's probably the reason why most of you are here, and that is the African Women in GIS and Digital Earth Africa Technical, let me rephrase that, the Digital Earth Africa and the African Women in GIS Technical Challenge Winners Announcement. It's been a program that's been running for a while. I'm not going to steal the thunder from our presenter who's going to tell us more about it. Representing Digital Earth Africa and who will tell us more about this collaboration, please join me in welcoming onto the virtual stage the Capacity Development Lead right here at Digital Earth Africa, Kenneth Mubia. Kenneth, the virtual stage is yours.
Thank you so much, Maud. Digital Earth Africa has been able to work with different stakeholders, and now specifically the young people living on behind. And thank you to the support from the Australian government. We were able to connect with the Africa Women in GIS sometime last year, just the same time we had the International Women's Day around March. We had a session with everybody. Then we had a specific training for the Africa Women in GIS sometime last year in May. And then the Africa Women in GIS, their mentors were able to select some of the projects that could support, and they were able to come up with a few that will actually be shown. And it has been quite a journey to actually see some of the mentors and the mentees whom we actually know from the continent, and also others from outside the continent. And now even the Africa is happy that we've actually expanded now in South Africa, and now we even have our own science lead, Dr. Lisa Libero, who will actually help with us in the various teams. The team has actually now added more diversity so that we're actually more in the capacity to support such a program, and also recognizing the various champions who've connected with us today, specifically Tina Babe connected from Addis. I know just in a few months, you'll be receiving some better news on your side, and other champions like Confidence in Ghana and others who've connected, Lele in Burkina Faso, and everybody who made the D Africa the one that we really want. And with this mentorship, we'll actually be able to see some of these announcements of the winners, and recognizing also the team that we've worked with, who are actually calling evenings and late in Australia, especially Rebecca. Thank you so much. And now over to Maud, our moderator. Thank you so much.
If I could be assisted to turn on my video introduction on the collaboration with African women in GIS. I came in late in the program, but when I saw that there was so much hype of activity, and it's lovely to see the ladies being showcased, the woman in GIS being showcased. It's certainly been an amazing, amazing program. And as we say here in Digital Earth Africa, we are leaving no one behind. So thank you so much to you, Ken, for that. At this point now, we're going to hand over, I've been saying this phrase for a lot, but now we're going to hand over to the leaders from this particular phrase I've been saying. We're now going to introduce the leadership team from the African Women in GIS. And to tell us a little bit more about this initiative or about this organization, please join me in welcoming onto the virtual stage Omowonulo Akintola. She loves to be called Ola. She is the mentorship lead of African Women in GIS. To tell us a little bit more about African Women in GIS, Ola, the virtual stage is yours. Over to you.
Yeah, thank you so much, Maud, and thank you everyone for joining the call today. Yeah, my name is Ola, and I'm the mentorship lead for African Women in GIS. So I'm just going to give a brief introduction about who we are as a community. So the African Women in GIS is a community of women who have a background in GIS and who are from the Africa or have African descent. So we have two co-founders, Chidima and Siana from Siana is from Ghana and Chidima is from Nigeria. So in 2017, Chidima created her own community in Nigeria, and in 2019, Siana created her own community in Ghana. So in June 2019, they both came together and decided that rather than have two separate communities in separate countries in Africa, it would be good to, to have one body for, the community. So the reason why, we have the community is to create a safe space for African women in the geospatial industry, irrespective of their career level. And our vision is to bridge the gender gap in the African geospatial industry. So far, we have women from all over Africa. We have women from over 30 countries. We have over 500 members, and we have social media followers of over 9,000. So far, we've been able to also contribute to the geospatial ecosystem in Africa, creating learning platform for women, also the mentorship program, and also awareness and networking initiative. So for the mentorship program, we started the mentorship program in 2020. That was when we had the first cohort. So we had the first cohort in 2020, and so far we've had other cohorts. So for the fourth cohort, which happened in 2022, we had a collaboration with Digital Earth Africa. Part of our mentees were able to, learn from the capacity development team on the sandbox tools, and part of the requirement for the program is that mentees would, use that platform to create their project, and then they submit a project. And after the project submission, we're able to, pick those who came up with very good projects, which you would be listening to today. So I just wanted to say thank you, Digital Earth Africa, for supporting us for the mentorship program. The feedback from the mentees have been that they've learned so much from the program, and it has really helped them on their career growth, on their career journey as well. If you're interested in joining the community, I'm going to drop a link to Google Forms, our membership form, so that you can sign up and you'll be added to our platform where you can also interact with other women. Once again, thank you so much, Digital Earth Africa, for this collaboration, and we really appreciate your support. Over to you, Maud.
Thank you so much to you, Ola. I'm so grateful that you are going to leave those details with us, because I was going to ask, how do we participate as women in GIS if we want to become part of the organization? I heard you saying more than 300 members across the continent. African Women in GIS is a huge organization. And so if you are someone in GIS and you're not part of African Women in GIS, the question is, why are you not? So I'm very excited. She's going to drop the details in the chat box. I see a lot of colleagues are saying, I'm from this country and I'm from this country. If you're a woman in GIS, let us know in the chat box which country you're representing on the continent, so that we can grow the circle of females across the continent. At this point, we're now going to go into the moment we've all been waiting for, where we're going to showcase the winning projects one at a time. You're also going to get to hear from those leaders and a little bit more about the mentorship program. And we're going to start with the runner-up. If her name and her slide could be showed on the screen, please allow me to introduce to you our runner-up, who is Sinethemba Mtshali. Sinethemba is based in South Africa, and her project was entitled Effects of the Migration Crisis in Africa. So tell us a little bit more about this project, exciting one indeed. Sinethemba, please turn on your microphone and your video. The stage is yours. Over to you.
Hello, everyone. I hope that you can hear me. It's such an honor to be here today. Thank you to the Africa as well as African Women in GIS. As you heard, I'm part of the 4th cohort of the mentorship program, and my project was chosen as the runner-up for the technical challenge. So just to give a background of the program in itself, I am a complete GIS novice, so I didn't know anything about it. I didn't study it in varsity or anything like that. But I saw the potential of remote sensing in terms of helping solving humanitarian problems on our continent. I truly believe that our environment tells a story of the quality of life of those living in those environments and people who are occupying those environments. So I joined the African Women in GIS mentorship program just to find some sort of accountability structure, in learning this technology as well as harnessing its potential. So I was able to join, and I was matched up with Dr. Jane Bemigisha she's the executive director of ESIPS International in Uganda, and she has also worked with Digital Earth Africa. So when I found out that we are able to have a webinar with Digital Earth Africa, I was really excited. And they introduced the sandbox to us, which was such a great platform for me as a novice and as a beginner in GIS, because I was able to use this analysis ready data for my own project, because delving into platforms such as QGIS and ArcGIS and even Google Earth Engine can be a bit daunting, but when you're able to use the sandbox with the notebooks that they have, it allows me to get the data that I need to create the project that we had to do for the mentorship program. So that was so amazing for me as well. And the mission that Digital Earth Africa has was very similar to what I had. I do believe that there's a big policy gap in terms of the information that policymakers are given. I feel like we need to provide more information for them so that they're able to make informed decisions. And Digital Earth Africa is really doing that with the sandbox. So the project that I have is called The Effects of the Migration Crisis on the African Continent. It started off as just understanding the refugee crisis in Uganda, specifically in the Bidi camp in the Yembe district. But it grew into understanding that it's not just a refugee crisis, but it's a migrant crisis, because some people might not be declared refugees because of documentation. They might not be given refugee status, but they are migrants and they're moving across borders for a better life, for economic reasons. And that's where it started. I decided to say, okay, I'm going to use a sandbox and use 2 locations as a case study. One of them was Bidi. The next one was the Moi Plus informal settlement, because we know that a lot of migrants move to informal settlements when they cross borders in search of a better life. And using the same methodology on 2 locations can help us really see and understand what's happening. So as you can see in front of you, these are my outcomes and the results. I used the forest monitoring notebook for the Bidi zone 1 and 2. And this just shows us how much forest loss has taken place in the area over time. And then I was able to use the urban change detection notebook as well in the Moi Plus informal settlement, so that we can understand the extent to which the environment is affected by the increase of migrants in these areas. So in the Bidi region, we can see that there's a lot of forest loss. And in the Moi Plus region, we can see that there's been a lot of growth, urban growth, meaning as more people come, this will just start to grow more, not only in the circumference or size, but also in density. And that's a big problem that we see here in South Africa, is these informal settlements are growing and they are providing unsafe regions. So can be fire hazards. There can be a lot of things that can happen in these areas that are unsafe, and they're not good living conditions for the migrants that are living in these countries. You can move on to the next slide, please. And then in this slide, you can see the urban change detection in the Bidi area. So this shows us that there is a steady influx of migrants that are continuing to occupy these areas. Forests and vegetations are at risk of deteriorating. And this can also result in the overpopulation of small areas of land. And then that increases, like we said, the risk of fires, severe pollution, and also just an overall unsafe living condition. So I truly believe that this project has so much more potential. We can move on to the next slide. And these are the 3 things that I just want to focus on with this project and take it even further than the platform that this technical challenge and African Women in GIS has provided me with. The 3 things that I really want to focus on is climate change. One of them is climate change, because as we know that we aren't big carbon emitters as a continent, but we are very vulnerable to the effects of climate change. So we need to use tools such as the sandbox to be able to monitor the effects as well as mitigate the risks in policy. If we speak about the African Free Continental Trade Area, that's opening up borders, to allow trade and to allow the free movement of trade. But if we haven't mitigated the risks that come with that, the traders themselves will be at risk. As we are seeing now, if people move across borders and they're living in unsafe conditions, then it does not benefit the traders themselves. Another big thing is the resettlement of refugees on the African continent. So during my research, I understood that a lot of migrants, once they've gotten their refugee status, they're resettled to the global north, so to the US, Canada, places like that, but they're never really resettled on the African continent. And I think that that's a big thing, that we can use remote sensing and GIS to find suitable places of resettlement so that refugees and asylum seekers can still remain on the continent, meaning that if they do have economic opportunity, they can build the continent that they live on and hopefully be able to return to their country of origin. But yeah, that's just the gist of my project. I just want to thank African Women in GIS once again, as well as the Digital Earth Africa platform.
Congratulations and well done to you, Sinethemba. It's been an honor just listening to your project, and we look forward to seeing it unfold in coming months. Please do keep us updated, whether it's on our social media platforms or yours. We'd really love to track the progress, and we look forward to seeing the success of it in coming months. Thank you and congratulations to you. And our winner from the African Women in GIS Technical Challenge, her name, and if the slide could come onto screen, please, is, if the slide could come onto screen, please. Her name is Jokotola Omidiji. She's based in Niger, but currently she is pursuing her PhD in New Zealand. It is a very, very early hour at the moment, so she's unfortunately not able to join us, but I will present on her behalf, and I really pray that I do justice to her winning presentation, which is entitled, or a winning project, that is, Monitoring Mangrove Forest Degradation in Parts of the Niger Delta, using freely available Earth observation data from Digital Earth Africa. Where and what of this particular project, the Niger Delta region, it's the largest river delta in Africa, and it features the 5th largest mangrove forest on Earth. The Niger Delta mangrove forest, the biodiversity hotspots, there are 3 that are designated as Ramsar wetlands of international importance, and it is also a hub for substantial oil and gas deposits. Field studies of the mangroves are limited, although they are amongst the worst degraded in the world, according to research. The region's volatility to conflicts and security concerns, as well as its difficult terrain that inhibits direct accessibility. So that is the where and the what. In terms of the how and the why of Jokotola's project, Earth observation data near real time, which is freely available and accessible, and mangroves and extreme climatic events require essential ecosystem resources and services and play a vital role in coastal zone protection and management. And on the next screen, if we could move there, there is this map of the study site. I'm assuming this is the map according to the key there. It's the map of Nigeria, which is highlighting Beliesoya State in southern Nigeria. The zoomed imagery is that of the study sites, the red bounded box covering Beliesoya, and number C, which is the third diagram in the middle, is the land cover map of Beliesoya State from Google Earth Engine. So thank you so much for her for including that study sites to give us context. And on the screen now is the objective or the aim of this project. It's to examine the spatio-temporal dynamics of parts of the Niger Delta mangroves and their health status in order to understand the factors that could likely be contributing to mangrove variability and degradation. And then on the next slide, the result is the change in mangrove extent and canopy status, and the range of this particular research is 2017 to 2021. And according to this, and if the Zoom master could just keep the slides coming so that I match the energy, about 80% increase in the aerial extent of mangroves between 2017 and 2019. Mr. Zoom Master, if you could continue, please. And I believe this is a diagram on the bottom right is a key that shows the mangrove status, the new and the old, which is diagram A. And then figure 2 is the spatial distribution map, which is showing the aerial extent of mangrove change between 2017 and 2021. And then figure C is the temporal pattern of mangrove changes between the same range of time. And then it's the NDVI map of change during the study. According to this mangrove clause, it's closed, which means it's mature. And that's the previous slide, Mr. Sumaster, please, if you could take us back. And it shows or depicts a consistent increase post 2029. Next slide, please. The results still continued. It's the same change in mangrove and water extent, this time from 1996 to 2017. So I'm assuming it's almost like a comparison in a range of about a few years. The consistent and significant loss of mangroves between 1996 and 2017, the regrowth of less than 1,500 hectares of mangroves between the same time range, and the mangroves changing to delta implies a loss of mangroves over time to water or flooded areas. Next slide, please, Mrs. Master. So in terms of the future work, I'm assuming this is the work that she will be doing, or Jokotola will be doing with regards to the project, is fourfold: the dynamics of coastal and inland forest ecosystems, shoreline and beach erosion monitoring, flood monitoring and disaster risk assessments, women, geoheritage and conservation studies, which include the UNESCO World Heritage Sites and marine protected areas. And last but certainly not least in the future work is the marine debris population, ecological footprint, and impact of plastics in African rivers and open seas. And then of course, she acknowledges people who are going to make this project possible. Firstly, African Women in GIS, the mentorship program, and she acknowledges her mentor, who was Deynaba Sek, Madame Deynaba Sek, and strengthening GIS skills, collaboration, and multidisciplinary research. And then in terms of the acknowledgements, the second one is Digital Earth Africa, which has assisted with the access to human resources and satellite data, coding skills, as well as open community. Is there a next slide, Mr. Zoom Master? I know that Jokotola would have done this presentation justice. I really tried my best to articulate it, but we're going to be tracking the progress of these two ladies as they continue working on these projects. And we look forward to telling you more about it as it unfolds. So well done and congratulations to the two ladies. If you're able to, if you could either use the emoticon of applaud, that would really be appreciated. Send your words of congratulations to Sinethemba and Jokotola using the comment section or the chat box. Let's show them some love. Why not? At this point, we're now going to present the certificates. Thank you so much, and congratulations, Sinethemba and Jokotola in absentia. On the screen now is the two certificates. The ladies have received them in their inbox, but I thought I'd show you as proof that they really did win this technical challenge. So on the left, Sinethemba Mtshali, with your project, Effects of the Migrant Crisis on the African Continent. Congratulations and well done to you. And then to our winner, she couldn't be here with us today, but she's here in spirit. Please let's show her some love. Jokotola Omidiji, and her project is Monitoring Mangrove Forest Degradation in parts of Niger Delta using freely available Earth observation data from Digital Earth Africa. A round of applause, please, for Jokotola. We don't want you to leave here without getting something from us. And so we want to connect with you, not only on hearing these two stories from the ladies and seeing how that unfolds, but also just following the conversations that are happening on our platforms. So on the screen is a way for you to do so. Please do connect with us. We both have websites, digitalearthafrica.org, as well as africanwomeningis.org. You can always just screen grab this page and get all the details at once. We're on email, info@digitalearthafrica.org, and community@africanwomeningis.org. We're both on Twitter as Digital Earth Africa and African Women in GIS, Digital Earth Africa and African Women in GIS on LinkedIn, and we're also on YouTube by the same name. You can have a choice of which platform you want to connect with us, but please do. We would love to connect with you and continue engaging on conversations of GIS and others within this Earth observation space. It's been an honor having everyone here. We want to take a photograph to capture this moment, to connect with you. And again, congratulations to Sinethemba and Jokotola on this exciting journey that lies ahead. Please keep us informed. We'd love to know the progress of your projects. Until we meet again, leaders, take care and be safe and have yourself a good day, a good afternoon, or a good night, depending on where you're joining us from. Take care and bye-bye. See you next week.